So here we are. We have an altitude drawn to the hypotenuse of a right triangle. The length of the altitude is, so the length of the altitude, that's Cn, is the geometric mean. So the first thing I see is the length of the altitude is Cn. That's the geometric mean. So it's going to be put in those two positions in the proportion between the segments of the hypotenuse. Between is the geometric mean between the segments of the hypotenuse. So the segments of the hypotenuse are AN and NE. AN and NE. Those are the two segments. Segment 1 and segment 2. I think that's a B. NB. This is a B right here. This is segment 2. These two segments make up the entire hypotenuse of AB. And this right here is a theorem. So if an altitude is drawn to the hypotenuse of a right triangle, then the altitude, it actually could be called a corollary, then the length of the altitude, which is Cn, let me highlight that, Cn, length of the altitude, is going to be the geometric mean between the two segments that make up the hypotenuse, An and NB. Now, they wrote Bn. Bn, the length from B to N is the same as the length from N to B. So that does not play a part. This is a pretty used proportion that we see with right triangles in this chapter. It's a nice relationship. There's another relationship we have here. If the altitude is drawn to the hypotenuse of a right triangle, so here we go again. The altitude is drawn to the hypotenuse of the right triangle. Then each leg is the geometric mean between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So here we have Cn, right? Cn, then each leg is the geometric mean. So here we've got Cn, that's the altitude that's drawn to the hypotenuse of a right triangle. But they're saying each leg. So here I have a leg, and here I have a leg. Each leg is the geometric mean. So let's look at the AC leg first. I'm going to have AC and AC. Well, what is it the geometric mean between? Between the hypotenuse and the segment of the hypotenuse. Between the hypotenuse and the segment of the hypotenuse that is adjacent to the leg. So here I have the hypotenuse. Write that, hypotenuse. Between the hypotenuse and the segment of the leg that is adjacent, or the segment of the hypotenuse that's adjacent to the leg. The segment of the hypotenuse adjacent to the leg. So that's AN. So we're going to have AB, AN. Now we also have another leg. So the other leg is CB. So CB is also a geometric mean between the hypotenuse AB and the segment that's adjacent to it. The segment of the hypotenuse that's adjacent to it. So it's NB. I actually really like this theorem because it's really not too difficult if you just practice it a couple times. So here, let's draw another one. And of course, I'm going to draw it a different way, just because you can look back up there and see that one. Let's draw now a right angle, and then I'm going to draw an altitude, and let's call this S-O-M-E. S-O-M-E. Okay. So here I have this this right triangle S-O-M. I drew an altitude O-E, and I want to create these proportions. So it said the legs, right? So I've got leg OM, and I've got leg OS. And then I've got my hypotenuse, which is SM. So let's start with OM first. OM is going to be a geometric mean between the hypotenuse, SM, and the part of that hypotenuse, the segment that's adjacent to OM. So the segment that's adjacent to OM is EM. I like it. Okay, let's try this again. Again, it's all knowing the words. So the leg OS, so let's look at the other leg. The other leg OS is the geometric mean between the hypotenuse, again, which is SM, and the leg, the portion of the hypotenuse that's adjacent to the leg. So that would be SE. So I would advise maybe working with these two ideas, this proportion right here, so this relationship with the geometric mean, and then also these similar triangles. So these similar triangles, just figuring out which triangles are similar to one another. This right here is a great picture because it's got color. So I would practice maybe drawing a right triangle and then using color, just so that you can get an idea of breaking those two triangles apart and creating the similarity statements. And with that practice, you should be able to see it a little bit more clearly. But this right here, this proportion, this geometric mean, and this geometric mean, getting those two straight, that will be very, very helpful. So we're going to now work with some arithmetic. And